Close your eyes and imagine yourself standing in a forest unlike any other. The air is cool and gentle, carrying with it the softest whisper of movement. Above you stretches a canopy of leaves that shimmer and dance, catching the light in a way that seems almost magical. You've entered the realm of the quaking aspen, known to scientists as Populus tremuloides, a tree whose very name speaks to its most enchanting quality. The aspens around you are doing what they've done for thousands upon thousands of years. They're quaking. Their leaves flutter and tremble in even the gentlest breeze, creating a sound like rain on a distant roof, or perhaps like whispered secrets passing through the forest. This perpetual motion isn't random or accidental. Each leaf hangs from a flattened stem called a petiole, shaped differently from most other trees. This flat stem acts like a hinge, allowing the leaf to twist and turn with the slightest movement of air, creating that signature shimmer that has captivated humans since we first walked beneath these trees. Look closely at the smooth bark surrounding you. It's pale, almost luminous, ranging from white to greenish-gray, with dark knots that look like watchful eyes scattered across the trunk. This isn't just beautiful to look at. The bark itself is alive with purpose, containing chlorophyll that allows the tree to photosynthesize even when it has dropped its leaves for winter. The aspen is so efficient, so determined to capture every possible ray of sunlight, that it has learned to breathe and feed through its very skin. Now let your mind wander to where you are. Quaking aspens are the most widely distributed tree species in North America, stretching from the cold reaches of Alaska and Canada all the way down to Mexico, from the Atlantic coast to the Pacific. You could be standing in any of these places, because the aspen has mastered the art of survival across an enormous range of climates and elevations. In the mountains, you might find them at heights of up to 12,000 feet, where few other trees dare to grow. But here's where the story becomes truly extraordinary. What if I told you that you're not standing in a forest of individual trees at all? Look around you again with this new knowledge. Those dozens, perhaps hundreds of aspens you see, all looking so similar with their white bark and trembling leaves, might actually be a single organism. Aspens are masters of cloning themselves, sending out underground root systems that sprout new trunks, creating what scientists call a clonal colony. Each tree, each trunk you see, might be connected beneath your feet to every other aspen in this grove, all sharing the same root system, all genetically identical. Consider the aspen grove called Pando, growing in Utah's Fish Lake National Forest. Pando, whose name means I spread in Latin, is considered one of the largest and heaviest living organisms on Earth, weighing an estimated 13 million pounds. This single clonal colony covers over 100 acres with approximately 47,000 individual stems, all connected, all one being. When you begin to see the aspens this way, the forest transforms before your inner eye. It's not a collection of separate trees competing for space and light. It's a single ancient entity, a vast underground consciousness expressing itself in thousands of white-barked fingers reaching toward the sky. The aspen trees surrounding you in your imagination are also remarkable timekeepers of the seasons. In autumn, they put on one of nature's most spectacular displays, transforming entire mountainsides into oceans of brilliant gold. The leaves turn in response to shorter days and cooler temperatures, the green chlorophyll breaking down to reveal the yellow pigments that were hidden there all along. People travel hundreds of miles just to witness this transformation, this annual reminder that beauty and change are inseparable. And when those golden leaves finally fall, carpeting the forest floor in a blanket of yellow that glows even on cloudy days, the aspen doesn't simply sleep through winter. Remember that chlorophyll in the bark. The tree continues its work, continues breathing and growing, even under snow, even in cold that would kill less hardy species. The aspen is a survivor, a pioneer species that is often among the first to reclaim land after fires or other disturbances. Let yourself sink deeper into this peaceful grove, feeling the rhythm of the aspens around you. Their quaking leaves create a sound that has been called nature's white noise, a constant, gentle susurration that can lull you into the deepest calm. The trees are patient. They have been here long before you arrived, and they will remain long after you've drifted into sleep, still trembling, still whispering their ancient stories to anyone who will listen. As you rest here in this tranquil aspen grove, let's journey deeper into the life story of these remarkable trees. Think about time for a moment. Think about how quickly things change in your own life, how the years seem to slip by faster and faster. Now consider that individual aspen trunks, the stems you see reaching upward around you, typically live between 40 to 150 years. Not an enormous lifespan compared to some trees, perhaps, but respectable. However, remember that what appears to be many trees is often one organism, and those root systems, that underground network connecting everything you see, can live for thousands upon thousands of years. Some scientists believe that certain aspen clonal colonies, like Pando, may be anywhere from 80,000 to 1 million years old, though estimates vary and exact dating is difficult. Imagine that. While human civilizations rose and fell, while ice ages came and went, while continents slowly drifted across the face of the earth, the aspens persisted, spreading their roots a little further each year, sending up new shoots, adapting, surviving. You're standing in the presence of something older than recorded history, older than agriculture, older than perhaps any other living thing. The aspens have survived so long partly because they're extraordinarily resilient to fire. In fact, they depend on it. When wildfire sweeps through a forest, many trees perish completely, their seeds destroyed, their future erased. But the aspen's roots lie safely beneath the soil, insulated from the flames above. Fire actually stimulates the aspen to send up new shoots, sometimes hundreds or thousands of them. Where there was once mature forest, within just a year or two, a dense thicket of young aspens appears, each stem perhaps only as thick as your thumb but growing with remarkable speed. These young trees can grow up to 3 feet in a single year under ideal conditions, racing toward the sunlight with youthful vigor. Picture these young aspens in your mind, a dense stand of slender trunks so close together you could barely walk between them. This crowding isn't accidental or unfortunate. It's strategy. The aspen understands that there's safety in numbers. Dense stands help protect individual stems from browsing animals like deer and elk, who find it harder to access the interior trees. As the grove matures over decades, natural thinning occurs. Some stems receive less light and gradually die back, while others grow stronger and thicker, eventually creating the more open, cathedral-like groves that you might be imagining now. Let's talk about those leaves again, the ones creating that perpetual gentle rustling above you. Each aspen leaf is roughly circular or heart-shaped, with fine teeth along its edges. In summer, they're a bright green, but not just any green. They're coated with a slightly waxy surface that gives them a luminous quality, making them seem to glow from within when the sun filters through. A mature aspen might have tens of thousands of these leaves, creating an enormous surface area for capturing sunlight and exchanging gases with the atmosphere. And speaking of the atmosphere, aspens are breathing with you right now, in this peaceful moment. Like all trees, they take in carbon dioxide and release oxygen through photosynthesis. But aspens are particularly efficient at this, their fast growth rate and photosynthetic bark making them excellent carbon sequesters. A single acre of healthy aspen forest can absorb and store significant amounts of carbon from the atmosphere each year, quietly working to keep the planet's systems in balance while you rest beneath their shade. The relationship between aspens and wildlife is another chapter in their long story. The groves around you are teeming with life, even if you can't see it all right now in your relaxed state. Woodpeckers drill into the soft aspen bark to feed on insects and excavate nest cavities. Later, when the woodpeckers have moved on, these cavities become homes for other birds, for squirrels, for flying squirrels that glide between the white trunks in the darkness. Owls watch from high branches. Bears mark their territory by clawing the bark. leaving dark vertical scars that tell stories of their passage. Elk and deer browse on young aspen shoots and strip bark from the trunks in winter when other food is scarce. Beavers particularly love aspens, their name in some Native American languages translating roughly to tree eater. A beaver can fell a small aspen in just a few minutes of determined gnawing, then feast on the nutritious bark and use the wood to build dams and lodges. These dams create ponds and wetlands, which in turn support entirely different ecosystems. The aspen gives and gives and gives, supporting web after web of interconnected life. Beneath the soil, something equally remarkable is happening. The aspen roots form partnerships. With mycorrhizal fungi, microscopic threads that weave through the soil and wrap around the tree's roots. This is a relationship of mutual benefit that has existed for millions of years. The fungi help the aspen absorb water and nutrients from the soil, particularly phosphorus, extending the tree's reach far beyond what its roots could accomplish alone. In return, the aspen shares some of the sugars it produces through photosynthesis, feeding the fungi that feed it. Everything is connected. Everything supports everything else. Even at the microscopic level, the aspen doesn't stand alone. Feel yourself settling even deeper into peace now, surrounded by these wise and ancient beings. The aspens continue their gentle quaking, that soothing whisper of leaf against leaf, a lullaby that has been playing since long before humans first heard it, and will continue long after we're gone. Let your mind drift now to the changing of the seasons, that eternal cycle the aspens know so intimately. Spring arrives in the aspen grove with a particular kind of magic. Before the leaves emerge, before that canopy of green unfolds above you, the aspens produce flowers. Yes, flowers, though not the kind you might imagine. These are catkins, long drooping clusters that appear in early spring, sometimes even before the snow has fully melted. The aspens are dioecious, meaning each clonal colony is either male or female, never both. Male trees produce reddish or yellowish catkins full of pollen, while female trees produce greenish catkins that will eventually develop seeds. These seeds are tiny, almost impossibly small, each one weighing less than a millionth of a pound. And yet, each seed comes equipped with its own transportation system, a cottony tuft of fine hairs that allows it to float on the wind like a miniature parachute. In late spring and early summer, these seeds are released by the millions, creating what looks like a gentle snowfall of white fluff drifting through the forest. The locals sometimes call it aspen snow. Most of these seeds will never germinate. They're viable for only a short time, perhaps just a few days or weeks, and they need very specific conditions. Bare, moist soil with plenty of sunlight. But among millions of seeds, some will find their perfect spot, and new genetic lines will begin. Though aspens rely primarily on their clonal root system to spread, these seeds represent possibility, genetic diversity, the chance for adaptation and change. In this way, the aspen balances two strategies: the reliable, steady expansion through roots, and the wildcard lottery of wind-borne seeds that might, just might, find a new place to begin an entirely new colony. Now imagine walking through this grove in the heat of summer. The temperature beneath the aspen canopy is noticeably cooler than in the open. Those thousands upon thousands of trembling leaves create dappled shade that shifts and changes moment by moment as the leaves catch different angles of light. This moving shade doesn't just make the grove a pleasant place for you to rest. It creates a unique environment for the plants growing at the aspen's feet. Unlike dense conifer forests where almost nothing grows in the deep shade, aspen groves have an understory rich with wild flowers, grasses, and shrubs. You might find lupins blooming purple, or bright yellow arrowleaf balsamroot, or delicate columbines nodding in the breeze. Berry bushes thrive here too: serviceberry, chokecherry, snowberry. The aspen's light, dappled shade and the nutrients its fallen leaves return to the soil create conditions where biodiversity flourishes. Scientists have found that aspen forests support a greater diversity of plant species than many other forest types in the regions where they grow. The aspen doesn't dominate and exclude. It shelters and invites. Consider for a moment the aspen's relationship with water. These trees are often found growing near streams, springs, and wet meadows, their roots seeking out moisture in the soil. But they're not confined to these wet places. Aspens have a remarkable ability to access water deep underground, their roots sometimes extending 30 feet or more below the surface to tap into groundwater. In this way, they can survive in places that seem too dry for such verdant growth. The tree acts as a kind of pump, drawing water up from the depths and releasing it into the air through transpiration, the evaporation of water from their leaves. On a hot summer day, a mature aspen can release hundreds of gallons of water into the atmosphere, contributing to local humidity and even influencing weather patterns. This transpiration creates another soothing sound in the grove. It's not something you can hear directly, but you can sense it. The coolness in the air, the feeling of moisture on your skin, the way the atmosphere beneath the aspens feels. Different, gentler, more alive than the dry world outside. The aspens are breathing, releasing the water they've drawn from deep within the earth, sharing it freely with the sky. Let's journey back in time for a moment to understand how long humans and aspens have known each other. Indigenous peoples across North America have lived among aspens for thousands of years, and they found countless uses for these generous trees. The inner bark could be eaten, particularly in late spring when it's sweet and tender, providing a valuable food source. The bark and leaves were used medicinally, containing salicin, the same compound that forms the basis of aspirin, to reduce fever and relieve pain. The straight trunks became poles for lodges and travois. The bark was used for tanning hides. Even aspen's cultural significance was profound, with some tribes carving messages and symbols into the soft bark, creating records that could last for decades. Later, European settlers discovered their own uses for aspen. The wood, while not as strong as oak or as rot-resistant as cedar, has its own valuable properties. It doesn't splinter easily, making it perfect for certain applications. It was used to make matchsticks by the billions, sauna benches that wouldn't give you splinters, tongue depressors, and popsicle sticks. Aspen pulp became paper, its fibers creating smooth, bright sheets. Even today, much of the aspen harvested commercially goes to making oriented strand board, or OSB, a construction material used in building homes. But the aspen's value extends far beyond what can be measured in board feet or economic terms. There's something about these groves that touches something deep in the human spirit. Perhaps it's that constant gentle motion, that whispering that never quite stops. Perhaps it's the way light filters through the canopy, creating an ever-shifting play of brightness and shadow. Perhaps it's knowing that you stand in the presence of something so ancient, so interconnected, so much larger than individual trees. People come to aspen groves seeking peace, seeking beauty, seeking something they might not even be able to name. And the aspens give it freely, as they have always given, asking nothing in return but the chance to continue their ancient dance of growth and renewal. Let yourself rest now in this knowledge, surrounded by these patient, generous beings. The quaking continues, steady as breath, gentle as the tide. As you drift deeper into relaxation, let's explore the aspen's remarkable ability to communicate and share resources. Remember that vast underground network of roots we spoke of earlier. Recent scientific discoveries have revealed that these connections are even more sophisticated than we once imagined. Through those intertwined root systems and the mycorrhizal fungal networks that link them, aspens can actually transfer nutrients, water, and even chemical signals from one part of the colony to another. A tree growing in deep shade, struggling to photosynthesize enough sugars to survive, can receive support from its sun-drenched neighbors. A tree with roots near water can share that precious resource with stems growing in drier soil. This sharing isn't limited to members of the same clone. Studies have shown that the fungal networks can connect different aspen colonies, and even different species of trees entirely, creating what scientists now call the wood wide web. Through this network, trees can send warning signals about insect attacks or disease, allowing their neighbors to activate defensive compounds before the threat arrives. The forest, which we once thought of as a collection of individuals competing for survival, is revealing itself to be something more like a community, or perhaps even a single vast organism, sharing and supporting and communicating in ways we're only beginning to understand. Imagine the complexity of it. Beneath your feet, in the darkness of the soil, millions of chemical conversations are taking place. Nutrients flowing through fungal highways, water being redistributed to where it's needed most, warnings spreading like ripples through an underground ocean. And above, in the sunlight, the aspens quake and shimmer, giving no obvious sign of all this hidden communication, this subterranean intelligence that keeps the grove healthy and resilient. Let's consider now the aspen's bark in more detail, that smooth, pale surface that makes these trees so instantly recognizable. The bark is thin, usually no more than a quarter-inch thick even on mature trees. This thinness is part of why it's so easy to carve, why bears leave such dramatic claw marks, why lovers through the ages have been tempted to scratch their initials into the yielding surface. But this thin bark comes with vulnerabilities. It offers little protection against intense heat or deep cold, which is one reason why aspens rarely survive as understory trees in dark forests. They need their light, their space, their specific conditions. That pale color serves a purpose beyond beauty. The white and greenish-gray tones reflect sunlight, helping to keep the tree from overheating in summer and protecting it from frost cracks in winter when the sun's rays can warm the bark during the day only to have it freeze again at night. The bark also contains lenticels, small pores that look like horizontal dark marks. These allow the tree to exchange gases with the air, part of how it continues to breathe and photosynthesize even when leafless. As aspens age, their bark changes character. Young aspens have smooth, almost luminous bark, but older trees develop darker, rougher bark near the base, with deep furrows and ridges. This thicker, corky bark provides better protection for the oldest part of the tree, though the upper trunk usually remains smooth and pale throughout the tree's life. These patterns of aging are written across the grove, allowing you to read the history of each stem if you know how to look. Think about the aspen's growth pattern through the seasons. In spring, as temperatures warm and snowmelt provides abundant moisture, the tree enters a period of explosive growth. New wood forms in a layer just beneath the bark called the cambium. This spring wood is light-colored and has large cells, built for rapid growth and efficient water transport. As summer progresses and conditions become less ideal, the tree produces summer wood, denser, darker, with smaller cells. Then growth stops entirely in autumn, and the tree enters dormancy. The following spring, the cycle begins again, creating a visible ring in the wood. Count these rings in a cut aspen trunk and you're counting years, reading a calendar written in wood. But here's something remarkable. Because aspen clonal colonies can live for thousands of years while individual stems live much shorter lives, the grove around you contains trees of many different ages simultaneously. Some stems might be just a few years old, slender and vigorous. Others might be approaching their maximum age, their bark dark and furrowed at the base, their crowns beginning to show signs of decline. And beneath them all, the roots continue their timeless work, ready to send up fresh shoots whenever space and light become available. The grove is constantly renewing itself, each generation of stems giving way to the next, while the true organism, the root system, simply continues. Consider the aspen's relationship with snow. In mountainous regions where aspens thrive, winter snowpack can be deep, sometimes accumulating to depths of 10 feet or more. The smooth, flexible young aspen stems can bend under this weight without breaking, bowing down to the ground if necessary, then springing back up when the snow melts. This flexibility, this ability to yield rather than resist, is part of what allows aspens to survive in harsh climates where more rigid trees would snap and perish. There's a kind of wisdom in this, a lesson written in wood and bark. Sometimes survival comes not from standing firm, but from bending, adapting, accepting what cannot be changed. In the depths of winter, when the aspen grove is dormant and buried in snow, life doesn't stop. Beneath the white blanket, the roots continue their slow work. Small mammals tunnel through the snow, feeding on bark and seeds cached in autumn. The dark marks on the bark, those old bare scratches and carved initials, stand out sharply against the snow, telling their stories to anyone who passes by. And the trees wait, patient as they have always been, for the return of spring, for the moment when they'll unfurl new leaves and begin the cycle once again. Let the peacefulness of this eternal cycle wash over you now. Growth and rest, expansion and dormancy, the reliable rhythm of seasons that the aspens have followed for longer than human memory can reach. Settle more deeply into comfort now, and let's explore the aspen's place in the larger story of the forest. Aspens are what ecologists call a pioneer species, among the very first trees to colonize disturbed land. After a fire sweeps through, after a landslide clears a slope, after logging or other disturbances create open space, the aspens arrive. Those wind-borne seeds we spoke of earlier can travel remarkable distances, sometimes many miles from the parent tree, searching for exactly this kind of opportunity. Bare soil, full sunlight, moisture, and no competition from established trees. Within just a few years of a major disturbance, what was once blackened earth or bare rock can become a dense thicket of young aspens, each stem reaching skyward with youthful determination. This rapid colonization serves a crucial purpose in the ecosystem. The aspens stabilize the soil with their roots, preventing erosion. Their leaves, falling each autumn, begin to build up organic matter, enriching soil that might have been depleted by fire or exposure. They create shade, moderating the harsh conditions of open ground. In doing so, they prepare the way for other species. For the aspen grove is not permanent. In many regions, aspens are what's called a successional species. They come first, grow fast, dominate for a time, but eventually they create conditions that favor other trees. Conifers like spruce or fir, which as seedlings need some shade and protection, begin to grow up beneath the aspen canopy. These conifers are shade tolerant in a way that aspens are not. Slowly, over decades or even centuries, the conifers grow taller, their dense evergreen crowns casting shade so deep that young aspen shoots struggle to survive. The aspen grove gradually transforms into a mixed forest, and then, if undisturbed, into a conifer forest where aspens persist only as scattered individuals or small groves in the sunniest spots. But remember, the roots remain. Beneath that conifer forest, the aspen's root system sleeps, waiting. It might wait decades. It might wait a century or more. And then when fire or windstorm or beetle outbreak creates an opening once again, up come the aspen shoots, reclaiming the land their roots never truly left. The cycle begins anew. In this way, the aspen is both temporary and eternal, both transient and patient, both pioneer and survivor. Let's turn our attention now to the incredible diversity of insects that call the aspen home. Scientists have identified over 300 species of insects that feed on or live in association with aspens. Some, like certain butterflies and moths, depend on aspens exclusively. Their caterpillars feed on aspen leaves and can survive on no other plant. The large aspen tortrix moth wraps aspen leaves around itself for protection. The poplar borer beetle spends years as a larva tunneling through aspen wood, creating elaborate galleries before emerging as an adult. Aphids cluster on young shoots, and predatory insects in turn feed on the aphids, creating chains of dependence that extend outward into the broader ecosystem. These insects, while they might seem like pests, actually play vital roles. They prune the trees, removing weak or damaged branches. They create entry points that fungi and bacteria can colonize, beginning the process of decomposition that will eventually return the tree's nutrients to the soil. They provide food for birds and bats and other insectivores. The aspen's generosity extends to these tiny creatures, offering itself as habitat and food, supporting the intricate web of life in countless small ways that add up to something profound. Think about the sound of the aspen grove in summer when it's full of life. The quaking of the leaves provides a constant background murmur, but listen more closely in your imagination. There's the drumming of woodpeckers, the songs of warblers and vireos that nest in the branches, the buzz of bees and flies visiting the small plants blooming in the understory, the rustle of a squirrel racing up a trunk, the distant bugle of an elk. Each sound is a thread in the tapestry, each creature a participant in the ongoing story of the grove. Aspens also have remarkable wound response capabilities. When a branch breaks or the bark is damaged, the tree quickly moves to seal the wound. It produces compounds that are toxic or unpalatable to insects and fungi, protecting the vulnerable exposed tissue. It begins to form callus tissue around the edges of the wound, gradually covering it over. If you look at an old scar on an aspen trunk, you'll often see how the bark has nearly closed over it, leaving only a dark line or a slight depression to mark where the injury occurred. The tree remembers its wounds, but it doesn't stop growing because of them. It simply adapts and continues. This resilience is mirrored in the aspen's response to browsing by deer and elk. When animals repeatedly feed on young aspen shoots, eating them down to near ground level, the tree responds by producing shoots with higher concentrations of defensive chemicals, compounds that taste bitter or cause digestive upset. It's a kind of learned response, the grove adjusting its chemistry to defend itself. Sometimes this works, and the browsing animals move on to more palatable food. Sometimes it doesn't work well enough, and young aspens in certain areas struggle to grow tall enough to escape the reach of hungry mouths. It's an ongoing negotiation between predator and prey, between the aspen's need to grow and the elk's need to eat, played out across countless groves in an ancient game of adaptation and counter-adaptation. Let yourself imagine now the aspen in all its seasonal moods. Spring, with its catkins and emerging leaves of the brightest green. Summer, with its full canopy casting dappled shade and its understory thick with wildflowers. Autumn, with that incomparable golden glow that seems to come from within the leaves themselves. Winter, with bare branches stark against the snow, the white bark glowing in low-angled light, everything simplified to its essential forms. Each season has its beauty, its purpose, its place in the eternal round. The aspens know this. They've lived through thousands upon thousands of these cycles, and they will live through thousands more, quaking and whispering, giving and growing, changing, and yet somehow always remaining themselves. Rest now in the constancy of that change, in the reliability of seasons, in the patient wisdom of trees that know how to bend but not break, how to share but not deplete, how to die back and yet never truly die. As you sink even deeper into tranquility, let's explore the aspen's relationship with light, for this is truly a tree that lives for the sun. Aspens require full sunlight to thrive, and they've evolved every aspect of their biology to capture as much of it as possible. Those trembling leaves aren't just beautiful, they're supremely efficient solar panels. Because they're constantly moving, turning different angles toward the sun, they can capture light throughout the day that a stationary leaf might miss. The quaking also helps prevent overheating, as the movement creates tiny air currents that cool the leaf surfaces. Scientists have measured the light levels in aspen groves and found something remarkable. While dense conifer forests might allow only 1 to 5% of sunlight to reach the forest floor, aspen groves typically allow 30 to 60% of light to filter through. This is why those understory wildflowers can flourish, why berry bushes thrive, why the groves feel so different from darker forests. The aspens don't hoard the light. They share it generously, their trembling leaves creating an ever-shifting mosaic of sun and shade below. This need for light explains much about where aspens grow. They favor slopes facing south or west, where they'll receive maximum sunlight. They thrive at the edges of meadows and clearings, where nothing blocks the sun's rays. In mountainous terrain, you'll often find them creating a distinct band of golden color in autumn, marking the elevation and exposure where conditions are just right, cold enough that competing conifers struggle but sunny enough for the aspens to flourish. These zones, often between 7,000 and 10,000 feet in elevation in the Rocky Mountains, become the aspen's domain. Let's consider now the aspen's wood itself, the substance of the tree. Aspen wood is relatively soft and light compared to hardwoods like oak or maple. When freshly cut, it's almost white or cream colored, though it darkens slightly with age and exposure to air. The wood grain is usually straight and fine, without the dramatic figure of woods like walnut or cherry. Some might call it plain, but there's beauty in this simplicity, a quiet elegance that doesn't demand attention but rewards close observation. The wood has one particularly interesting property. It's nearly odorless and tasteless, and it doesn't impart flavors to other materials. This made it ideal for shipping crates and containers for food products. It was used to make barrels for storing flour, butter, and other goods that needed to be kept pure and untainted. In Scandinavia, thin sheets of aspen were used to wrap and preserve food. Even today, some cheesemakers prefer aspen boards for their aging rooms because the wood doesn't affect the cheese's flavor development. Inside a living aspen, the wood serves as more than just structure. It's a transportation network, with vessels that carry water and dissolved minerals up from the roots to the leaves, sometimes climbing over 60 feet or more from soil to canopy. Other cells carry the sugars produced by photosynthesis downward to feed the roots and fuel new growth. This two-way highway of nutrients never stops flowing during the growing season. Millions of molecules moving through microscopic channels in a choreography of perfect efficiency. Think about the aspen's relationship with carbon, that fundamental element that forms the basis of all life. Every aspen tree is built primarily from carbon atoms that were once floating freely in the atmosphere as carbon dioxide. Through photosynthesis, the tree captures these carbon atoms and incorporates them into wood, bark, leaves, and roots. A mature aspen stem might contain several hundred pounds of carbon, all of it pulled from thin air through the miracle of photosynthesis. When you stand in an aspen grove, you're surrounded by air made solid, by atmosphere transformed into living wood through nothing more than sunlight, water, and the patient work of chlorophyll. The aspen's leaves deserve one more moment of our attention. Consider their size, typically about 2 to 3 inches across, neither tiny nor enormous but perfectly proportioned for their purpose. Consider their number. A mature tree might have 200,000 leaves or more, creating an enormous surface area for capturing light and exchanging gases. Consider their lifespan. Each leaf lives for only one growing season, from spring bud break to autumn leaf fall, perhaps 5 or 6 months. And yet in that brief time, each leaf will have photosynthesized hundreds of times its own weight in sugars, contributing its part to the tree's growth and survival. When autumn arrives and the leaves prepare to fall, the tree doesn't simply abandon them. It carefully withdraws nutrients, particularly nitrogen, breaking down chlorophyll and reabsorbing the valuable compounds it contains. This is why leaves turn yellow rather than simply dying green and brown. The gold you see in autumn is the color that was always there, hidden beneath the chlorophyll green, finally revealed as the green pigments are dismantled and taken back into the tree for storage over winter. Nothing is wasted. Everything is recycled. The aspen is supremely efficient, the product of millions of years of evolution refining every process to perfection. Once those leaves fall and carpet the forest floor, they begin their final gift to the grove. Aspen leaves decompose relatively quickly compared to conifer needles, breaking down within a year or two. As they decay, they release their nutrients back into the soil, enriching it for the next generation. They provide habitat for countless soil organisms, bacteria, fungi, springtails, mites, beetles, earthworms. These decomposers break down the leaves into humus, that rich, dark, crumbly substance that makes soil fertile and alive. The leaves that trembled in the summer breeze become the foundation for next year's growth, completing the cycle in the most elegant way imaginable. Let yourself be held now by the knowledge of these cycles within cycles, these patterns of giving and receiving that have no beginning and no end. The aspens continue their ancient work around you, breathing, growing, sharing, preparing for whatever comes next with the calm assurance that comes from knowing they've survived everything that the millennia have thrown at them. And they will continue, quaking and golden, whispering their secrets to anyone patient. Enough to listen. Allow yourself to drift even deeper now, into a state of perfect relaxation, as we explore the aspen's survival strategies in greater detail. The aspen has developed remarkable defenses against the many creatures that would consume it. In addition to the chemical compounds we've mentioned, aspens produce phenolic compounds and tannins that accumulate in their bark and leaves. These substances taste bitter and can interfere with an animal's ability to digest the plant tissue. The concentration of these defensive chemicals varies throughout the year, often being highest in winter when other food sources are scarce and browsing pressure is greatest. But the aspen's defenses are not absolute, nor should they be. Some herbivory is actually beneficial to the grove. Moderate browsing can stimulate new growth and increase the density of aspen stands. It's a delicate balance, this negotiation between the tree and the creatures that feed upon it. Too much browsing can prevent aspens from regenerating successfully. Too little, and the grove might not maintain the vigor and diversity that comes from constant renewal. The aspen has learned to live within this balance, accepting some loss as the price of being part of a living ecosystem. Consider now the aspen's response to drought, for water is life, and there are times when water becomes scarce. Aspens have evolved several strategies to cope with dry conditions. They can close the stomata on their leaves, the tiny pores through which water evaporates and carbon dioxide enters. This reduces water loss but also reduces photosynthesis, a trade-off the tree must carefully manage. In severe drought, aspens may drop some of their leaves early, reducing the surface area from which water can evaporate. The deep roots we spoke of earlier become crucial during these times, reaching down to water sources that shallower-rooted plants cannot access. Extended drought can cause dieback in aspen groves, with individual stems dying while the root system survives. This phenomenon, called sudden aspen decline, has affected many groves in recent decades, particularly in the American Southwest where drought has become more frequent and severe. Scientists studying this have found that while individual stems may die, the root system often persists, ready to send up new shoots when conditions improve. The aspen bends with circumstances, adapts, endures. It has survived ice, ages and warming periods, droughts and floods, and it carries within its genes the memory of all these challenges. Let's turn our attention to the way aspens reproduce through their roots, a process called suckering. When conditions are right, the parent root system sends out lateral roots that can extend many feet from the original stem. At intervals along these roots, adventitious buds form. These buds can remain dormant for years, but when triggered by the right signals, perhaps damage to nearby stems, perhaps a change in light levels, perhaps hormonal signals traveling through the root system, they sprout, sending shoots up through the soil to become new stems. This process can create aspen groves that expand outward in a roughly circular pattern, with the oldest stems near the center and progressively younger stems toward the edges. Some clonal colonies have been estimated to expand at a rate of about 3 feet per year, a slow but steady claiming of territory that can, over centuries or millennia, cover enormous areas. Each new stem is genetically identical to every other stem in the colony, but epigenetic factors, environmental influences on gene expression, mean that each stem might respond slightly differently to its specific conditions. The grove has unity in diversity, sameness in variation. Think about the buds that form on aspen branches each autumn, preparing for the following spring. These buds are marvels of miniaturization and protection. Inside each bud, protected by overlapping scales, are the embryonic leaves or flowers for next year's growth, already formed, just waiting for the right conditions to emerge. The buds are coated with a sticky resin that protects them from desiccation and cold, and that gives them a distinctive shine and scent. These buds will remain dormant through the entire winter, surviving temperatures that might drop to 40 degrees below zero or even colder, waiting patiently for the warmth and lengthening days of spring to trigger their opening. The timing of bud break in spring is crucial. Open too early and a late frost might kill the tender new leaves. Open too late and the tree loses precious growing time. Aspens have evolved to respond to a combination of signals: accumulated warmth over several weeks, day length, and possibly other environmental cues we don't fully understand. Different clonal colonies, even ones growing near each other, might leaf out at slightly different times, their genetic programming dictating slightly different responses to the same environmental conditions. This variation is itself a survival strategy, hedging bets against the unpredictability of spring weather. Imagine the grove in that moment of spring awakening. The buds swell, the scales separate, and suddenly, within just a few days, the entire grove transforms from bare branches to a haze of fresh green. The new leaves emerge folded and pale, then gradually expand and darken as their chlorophyll systems activate. Within a week or two, the grove has shifted from winter's starkness to spring's verdant promise, and the work of another growing season begins. The aspen's ability to reproduce both sexually through seeds and asexually through root sprouts gives it remarkable flexibility. Seeds allow for genetic diversity and long-distance colonization. Root sprouts allow for rapid, reliable expansion and persistence even when seed production fails or conditions aren't right for seed germination. Many aspen groves rely primarily on vegetative reproduction, going decades or even centuries without successfully establishing from seed. And yet the trees continue producing seeds each year, millions upon millions of them, just in case. Just in case conditions are perfect. Just in case this is the year for new genetics, for new possibilities, for adaptation to changing times. Rest in this knowledge now, in the understanding that the aspens around you carry within them both ancient persistence and eternal possibility, both the certainty of clonal continuation and the lottery of genetic innovation. They are old and forever young, unchanging and constantly adapting, deeply rooted and endlessly reaching upward toward light. Sink deeper still into this peaceful state, and let's explore the aspen's place in the mythology and folklore of the people who have lived among these trees. Many cultures have woven stories around the quaking aspen, trying to explain that constant trembling. One Christian legend says that the aspen was the wood used to make the cross, and the tree has trembled with shame and sorrow ever since. Another story says that the aspen was the only tree that refused to bow when Christ passed, and it was cursed to tremble forever in fear. Indigenous peoples of North America told different stories. Some said the aspen trembled because it was sensitive to the spirits moving through the forest, always aware of the unseen world. Others said the leaves whispered messages from ancestors or carried prayers to the sky. These stories, whether you believe them or not, speak to something real: the human need to understand and explain the natural world, and the deep impression these trembling trees make on the human imagination. For thousands of years, people have stood beneath aspens and felt something: peace, perhaps, or wonder, or a sense of connection to something larger than themselves. The scientific explanations we have now, understanding the flattened petioles and the physics of how they catch the wind, don't diminish this feeling. If anything, the truth is more marvelous than any myth. Let's consider the aspen's role in art and literature. The golden autumn colors of aspen groves have inspired countless painters, photographers, and poets. The quaking leaves have been compared to fluttering handkerchiefs, to coins catching the light, to the shimmer of water, to countless other things that move and gleam and capture attention. Writers have used aspens as symbols of impermanence, of natural beauty, of the changing seasons of life. Artists have tried to capture that particular quality of light in an aspen grove, the way it seems to glow from within, the way shadows and brightness shift moment by moment in a dance that never repeats exactly the same way twice. In more recent times, aspens have become important subjects for scientific research on climate change. Because they're sensitive to temperature and moisture conditions, and because they grow across such a wide range of latitudes and elevations, aspens serve as indicators of how ecosystems are responding to a warming world. Scientists monitor aspen groves, tracking when they leaf out in spring, when they turn gold in autumn, how well they're regenerating, where they're thriving and where they're declining. The aspens, in their silent way, are telling us stories about the health of the planet, if we're willing to listen. Think about the relationship between aspens and fire once more, but from a different angle. Fire isn't just something the aspen survives. It's something the aspen ecosystem actually needs periodically. Without occasional fire, many aspen groves would eventually be replaced by conifers, as we discussed earlier. But there's more to it than that. Fire releases nutrients locked up in dead plant matter, returning them to the soil in forms that living plants can use. It clears out understory vegetation, reducing competition. It resets the system, creating the conditions for a burst of new growth and biodiversity. Indigenous peoples understood this. Many practiced intentional burning, setting small fires to manage the landscape. These fires kept forests open and park-like, promoted the growth of berry bushes and other useful plants, and maintained diverse habitats for game animals. The aspen groves benefited from this management, sprouting vigorously after fires and providing food and materials for both people and animals. When fire suppression became policy in the 20th century, many aspen groves began to decline, gradually giving way to denser, darker forests. We're only now relearning what traditional peoples always knew. Fire is not the enemy of the forest, but part of its natural rhythm. Consider the way sound travels in an aspen grove. The leaves create their own acoustic environment, a constant soft rustling that masks other sounds and creates a sense of privacy and enclosure, even in an open forest. This sound has been measured at around 40 to 50 decibels when there's a moderate breeze, about the volume of a quiet library or soft rainfall. Studies have shown that natural sounds at this volume and frequency can reduce stress, lower blood pressure, and promote relaxation in humans. Perhaps this is part of why people find aspen groves so peaceful, so conducive to contemplation. The trees are literally creating a soundscape that calms the nervous system. The aspen's relationship with soil fungi extends beyond the mycorrhizal partnerships we mentioned earlier. Many species of mushrooms fruit from aspen roots and decaying aspen wood. Some of these are choice edibles, sought after by foragers: oyster mushrooms growing on dead logs, honey mushrooms at the base of living trees, and various boletes associating with aspen roots. These mushrooms are the fruiting bodies of vast fungal networks underground, networks that might weigh more than all the tree biomass visible above ground. The grove you're imagining has an invisible mirror image beneath the soil, a dark network of fungal threads extending through the earth, connecting, communicating, sharing. Think about the texture of aspen bark under your hand. It's smooth, almost like skin, slightly cool to the touch. If you were to press your fingers against it, you might feel the tree's life. Beneath, the cambium layer growing, the vessels carrying water upward, the slow pulse of sap. Trees don't have heartbeats, of course, but there's a rhythm to them nonetheless. The rhythm of seasons, of day and night, of growth and dormancy. Place your imaginary hand against the bark and feel that rhythm, that aliveness, that patient, ongoing existence that makes our brief human lives seem like mayfly flickers in comparison. The aspen teaches patience. It teaches resilience. It teaches the wisdom of bending rather than breaking, of sharing rather than hoarding, of trusting in cycles, of releasing what no longer serves and keeping only what's essential. It teaches that death is not an ending but a transformation, that what falls becomes what rises, that nothing is truly lost. These lessons are written in wood and root and trembling leaf, available to anyone who spends time in the presence of these trees, who listens to their whispering, who allows their peace to seep into stressed and hurried human hearts. Let that peace settle over you now like falling leaves, like snow, like the gentlest rain. The aspens continue their eternal work, and you can rest, knowing that some things endure, some beauty persists, some wisdom remains constant through all the changes time brings. Drift deeper now, into the most restful state, as we explore the final layers of the aspen story. Let's consider how aspens interact with water in ways beyond what we've already discussed. Aspens are what ecologists call phreatophytes, plants with roots that tap into groundwater or the water table. This ability allows them to create oases of green even in relatively dry landscapes, their roots finding moisture that other plants cannot reach. In doing so, they moderate the local climate, increasing humidity and creating cooler microclimates within their groves. Small springs and seeps are often surrounded by aspens, their white trunks marking water sources from a distance. These water-seeking roots also help filter and purify groundwater. As water moves through the soil and encounters aspen roots and their associated fungi and bacteria, contaminants can be absorbed, broken down, or transformed. The grove acts as a living filter, improving water quality for the streams and rivers downstream. This is yet another of the aspen's quiet gifts to the broader ecosystem, a service performed without fanfare or recognition, simply as part of being what it is. Think about the age structure of an aspen grove in more detail. Because all the stems in a clonal colony come from the same root system, you might expect them all to be the same age, but this is rarely the case. Different stems sprout at different times, responding to different disturbances or opportunities. You might have stems that are 150 years old standing next to stems that sprouted just 5 years ago. This multi-aged structure creates a complex canopy with gaps and openings at different heights, increasing the structural diversity of the forest and creating niches for different species of birds, insects, and other organisms. The oldest stems in a grove often develop heart rot, a fungal decay of the central wood. While this might seem like a weakness, it's actually important for wildlife. The soft, decaying heartwood is easily excavated by primary cavity nesters like woodpeckers, who create holes that later become homes for owls, bats, flying squirrels, and many other species. A grove with old, partially decayed stems supports more wildlife than a grove of only young, vigorous trees. Decay is part of health, death feeds life, and the aspens demonstrate this principle in the most tangible way. Let's consider the aspen's response to elevation and climate. As you move up a mountain, conditions change. Temperatures drop, growing seasons short, snow remains longer, and winds grow stronger. Aspens adapt their form to these changing conditions. At lower elevations, they might grow tall and straight, reaching 60 or 70 feet in height. Higher up, they become shorter and stockier, their trunks twisted by wind, their branches flagged to one side by prevailing storms. At the upper edge of their range, near tree line, aspens might form low, shrubby thickets called krummholz, barely taller than a person, clinging to existence in one of the harshest environments trees can survive. This ability to modify their form while remaining genetically the same is remarkable. The same clone that grows tall and majestic at 7,000 feet might become stunted and wind-sculpted at 11,000 feet. It's the environment speaking through the genes, telling the tree what shape it needs to be to survive in this particular place. The aspen listens and adapts, never questioning, never resisting, simply becoming what it needs to be. Consider the role of aspens in preventing erosion. Those extensive root systems, sometimes extending 40 feet or more from the trunk, bind the soil together with incredible strength. On steep slopes, in areas prone to landslides, along stream banks threatened by flooding, aspens stabilize the ground. Their roots create a living net that holds soil in place even during heavy rains or rapid snowmelt. When roads are built through aspen groves, engineers often try to preserve the trees specifically because their roots help maintain slope stability. The aspen protects not just itself, but the very ground it stands on, and everything downstream that might be affected by erosion. Think about the seasonal changes in the aspen's photosynthetic strategy. In spring and early summer, when moisture is abundant and conditions are ideal, the tree produces sun leaves optimized for high light conditions, with thick cuticles and dense chlorophyll. As summer progresses and conditions become hotter and drier, new leaves that emerge might be slightly different, adapted to conserve water and cope with stress. And remember that photosynthetic bark, working year-round but especially important in early spring and late fall when the tree is leafless. Scientists estimate it might contribute anywhere from 5 to 25% of the tree's annual carbon fixation, a significant amount for tissue that most trees treat as purely protective. The aspen's influence extends to the soil chemistry beneath it. Aspen leaves, being relatively high in nutrients compared to conifer needles, decompose to create a slightly more alkaline, nutrient-rich soil. This affects which plants can grow in the understory, which insects and soil organisms thrive, which nutrients are available for the aspen's own uptake. The tree literally creates the ground beneath its feet, transforming the soil over decades into something uniquely suited to its own needs and to the community of life it supports. Imagine now the aspen grove through the cycle of a single day. Dawn breaks and the leaves, which hung still in the pre-dawn calm, begin to tremble as the warming air starts to move. Songbirds greet the day from high branches. As the sun rises higher, light filters through the canopy in ever-shifting patterns. Photosynthesis accelerates, stomata open. Water begins its journey from roots to leaves to atmosphere. Midday brings peak activity. Insects buzzing, squirrels chattering, the leaves in constant motion. Afternoon sees a gradual settling, though the wind rarely stops. Completely. Evening brings calm, the leaves gradually stilling as temperatures drop and air movement slows. Night falls and the grove grows quiet though life continues. Owls hunt, fungi extend their hyphae another microscopic increment, roots continue their slow exploration of the soil, buds wait patiently for spring. And then dawn comes again, and the cycle continues day after day, year after year, millennium after millennium. Rest in this eternal rhythm now. Let the constancy of the aspen's existence calm your mind. Let the knowledge of their ancient patience soothe your worries. The trees have seen so much, weathered so much, adapted to so much, and they remain, trembling gently, golden in season, forever generous, forever patient, forever wise in their wordless way. As we approach the end of our journey through the world of the quaking aspen, allow yourself to settle into the deepest relaxation, knowing that the aspens will continue their story long after our time together ends. Let's consider a few final aspects of these remarkable trees, thoughts to carry with you into sleep. Think about the aspen's relationship with lightning. Those tall, white trunks standing alone or in groves on mountainsides are natural lightning rods, and they're struck more often than you might imagine. When lightning hits an aspen, the electrical charge often travels down through the water-conducting vessels just beneath the bark, sometimes creating a spiral scar as it descends, sometimes killing the tree, sometimes leaving it merely marked but alive. These lightning scars become part of the tree's story, dark vertical lines on white bark, evidence of survival, reminders that even sudden violence can be endured. And remember, even if the visible stem dies, the roots persist, ready to send up new growth. The aspen's ability to reproduce vegetatively means that genetic diversity within individual groves can be quite low, since all stems are clones. However, across the landscape, there's often tremendous genetic diversity between different clones. Scientists have found that neighboring aspen groves can be as genetically different from each other as oak trees from different continents. Each clone represents a unique genetic individual, shaped by different evolutionary pressures, different random mutations accumulated over millennia. Some clones are more resistant to drought, others to disease, others to browsing. This diversity, spread across the landscape, is a kind of genetic library, a repository of solutions to survival problems, some of which may become crucial as climates and conditions change. Consider the phenomenon of fall colors one more time, but with deeper understanding. Not all aspen leaves turn the same shade of gold. Some become brilliant yellow, others more orange or even reddish. These variations are partly due to genetics. Different clones produce different ratios of pigments, and partly due to environmental conditions. Temperature, moisture, light exposure, and soil nutrients all influence the final colors. A single grove, if it contains multiple clones, might display several shades of gold simultaneously in autumn, creating a tapestry more complex than it first appears. The diversity is hidden until autumn reveals it. Think about the aspen as a keystone species in many ecosystems where it grows. Remove the aspens and the whole system shifts. The species that depend on aspen bark for winter food struggle or disappear. The cavity nesting birds lose their homes. The understory plants that thrive in dappled shade decline. The soil changes, becoming less rich, less able to support diverse life. The water cycle shifts as transpiration decreases. The landscape becomes less resilient to fire, less able to recover from disturbance. The aspen, in its humble way, holds together entire webs of relationship, entire communities of life. Its importance is far greater than its individual presence might suggest. Let's talk about the future of aspens. Climate change presents challenges. Hotter, drier conditions in many regions, more severe droughts, changing fire patterns, new pests and diseases spreading into areas where aspens haven't evolved defenses against them. Some aspen groves are declining, particularly at the warmer, drier edges of the species range. And yet, aspens have survived massive climate shifts before. They persisted through ice ages and warming periods. Their genetic diversity, their ability to reproduce both sexually and asexually, their capacity for rapid growth and adaptation, all of these give hope that aspens will find ways to persist, perhaps shifting their ranges, perhaps evolving new defenses, perhaps simply enduring as they have always endured. Consider that in some places, aspens are expanding their range. In the Arctic, as tundra warms, aspens are among the trees marching northward, colonizing areas that were too cold for them just decades ago. They're flexible, opportunistic, ready to claim new territory when conditions allow. The species that has spread across an entire continent isn't likely to give up easily. Think about what we can learn from aspens about community and connection. The way they share resources through root connections, the way they support struggling members of the colony, the way they create conditions that allow countless other species to thrive. These are lessons worth pondering. In a world that often seems to celebrate competition and individual achievement above all else, the aspen reminds us that cooperation, sharing, and creating conditions for others to flourish might be equally important strategies for success and survival. The aspen teaches us about the relationship between individual and collective. Each stem is distinct, occupying its own space, reaching toward its own patch of sky. And yet beneath the surface all are connected, all are one. This paradox, individuality and unity coexisting, neither negating the other, is one of the profound truths the aspen embodies. We are separate and together, alone and connected, individuals and parts of something larger. The aspen knows this in its very structure. As you prepare to drift into sleep, imagine yourself becoming part of the aspen grove. Your breath synchronizes with the quaking of the leaves. Your heartbeat slows to match the patient rhythm of seasons. Your thoughts settle like leaves falling in autumn, each one finding its place, contributing to the rich humus of rest from which tomorrow's growth will spring. You are held by roots deeper than you can see, supported by connections you can't fully understand, part of a community that includes every living thing that shares this planet with you. The aspens will stand through the night, as they have stood through countless nights before. They'll be there in the morning, still quaking, still whispering, still generous with their shade and their beauty and their quiet wisdom. And you can return to them whenever you need to, in imagination if not in body, finding beneath their trembling canopy the peace that comes from connecting with something ancient, something enduring, something infinitely patient and kind. Sleep now as the forest sleeps, trusting in cycles, trusting in renewal, trusting that when you wake, the world will still be turning, the seasons will still be changing, and somewhere on a mountainside or in a valley, aspen leaves will be catching the light and trembling in the eternal dance that gives them their name. The quaking aspens whisper their final blessing. Rest well, grow strong, and remember that you, too, are rooted in something larger than yourself. Something that will endure. Something that connects you to all of life in ways both seen and unseen. Good night.